Question 1. In the context of relational database design, Maria, a database architect, is developing a system for a university where each student can enroll in multiple courses and each course can have multiple students. She must represent these relationships efficiently in a relational database. Given this many-to-many relationship scenario, what should Maria do to correctly model this in the relational schema? A. Create a single table combining students and courses, listing all enrolled students for each course in one attribute. B. Create two separate tables for students and courses and a third junction table that includes foreign keys referencing both students and courses. C. Use a one-to-one relationship between students and courses to ensure unique mapping. D. Duplicate student records for each course enrollment to avoid conflict. Answer. Correct answer. B. Explanation. A many-to-many relationship cannot be directly represented in relational databases as a single table due to normalization rules and the need to avoid redundancy. The proper approach is to create two entity tables, students and courses, and a third junction associative table that references the primary keys of both to represent enrollments. This maintains data integrity and supports efficient querying. Option A violates first normal form by storing multiple values in a single attribute. Option C incorrectly applies one-to-one relationships, which do not model many-to-many scenarios. Option D leads to redundancy and anomalies. This method aligns with standard database design methodology and normalization principles as outlined in relational model theory. Question 2. Given the circumstances, Mr. Lee is designing a database and wants to ensure that no attribute in any relation contains repeating groups or arrays. He also aims to have every attribute dependent only on the primary key to avoid data anomalies. What level of normalization should Mr. Lee apply to his relations? A. First normal form 1 for only. B. Second normal form 2. C. Third normal form 3. D. Boy Scott normal for a year. Answer. Correct answer. C. Explanation. First normal form 1 ensures that all attributes are atomic, no repeating groups. Second normal form 2 addresses partial dependency, meaning all non-key attributes depend on the entire primary key, important for composite keys. Third normal form 3 eliminates transitive dependencies, non-key attributes depending on other non-key attributes, ensuring every non-key attribute only on the primary key. BCF is stricter and handles certain anomalies beyond 3. Since Mr. Lee wants to avoid repeating groups and have all attributes depend only on the primary key, 3 is the appropriate target normalization level as it reduces redundancy and prevents update anomalies consistent with normalization theory. Question 3. Based on the information, Sandra is working with an SQL database where she needs to control who can update certain sensitive tables. She wants to grant permissions selectively without giving full control over the database. Which type of SQL commands should Sandra use to accomplish this? A. Data definition language, DDL. B. Data manipulation language, DML. C. Data control language, DCL. D. Transaction control language, TCL. Answer. Correct answer. C. Explanation. Data control language DCL commands such as grun and revoke are used to control access and permissions on database objects, allowing administrators or users to selectively assign rights like select, insert, update, or delete. DEL manages the structure of database objects. Create, alter, drop. DMOs used to manipulate data within tables. Select, insert, update, delete to see. Commands manage transactions, commit, rollback. Sandra's goal to manage user permissions aligns with DCL commands following best practices for database security and authorization. Question 4. When analyzing the characteristics of relations, John notices that a relation table has attributes that are atomic. Each tuple is unique, and the order of tuples and attributes is irrelevant. However, he is unsure why ensuring attribute domains is important. What role do attribute domains play in defining a valid relation? A. Domains define the physical storage size of attributes. B. Domains restrict the permissible values for each attribute, ensuring data consistency and integrity. C. Domains dictate the order in which attributes must appear in tuples. D. Domains specify that all attributes must be nullable. Answer. Correct answer. B. Explanation. In the relational model, the domain defines the set of allowable values an attribute can take. Data type range constraints. This ensures consistency and integrity by preventing invalid data from being entered. It does not affect storage size directly. A. Or attribute order. C. Nullable constraints relate to whether an attribute can hold null values, not the domain itself. D. Enforcing domains is critical. Maintaining data quality and follows integrity constraint principles outlined in database theory. Question 5. As demonstrated by recent database design best practices, Michael is considering denormalization for a high-traffic online retail system to improve query performance. However, he is concerned about potential drawbacks. What is the primary trade-off Michael should expect when choosing to denormalize? A. Increased data redundancy and potential anomalies in exchange for faster read queries. B. Improved data consistency with no impact on performance. C. Reduced storage requirements due to removal of redundant data. D. Simplified data model without affecting update complexity. Answer. Correct answer. A. Explanation. Denormalization intentionally introduces controlled redundancy to optimize query performance, especially read-heavy workloads, by reducing the number of joins needed. However, this comes with increased risk of data anomalies, update insert delete anomalies, and requires careful management of consistency through additional application or database logic. It does not improve data consistency. B. Nor reduce storage. C. The data model becomes more complex rather than simpler. D. This trade-off is well documented in database design literature regarding physical database design and performance tuning. Question 6. Throughout the course of implementing transactions, Emma wants to ensure that her system adheres to the ACID properties. If her database crashes after some transactions were partially processed, which ACID property ensures that the database can be restored to a consistent state without partial changes? A. Atomicity. B. Consistency. C. Isolation. D. Durability. Answer. Correct answer. A. Explanation. Atomicity guarantees that all parts of a transaction are completed successfully as a single unit. If any part fails, the entire transaction is rolled back, preventing partial updates. This property is critical for recovery from failures like crashes. Consistency ensures the database moves from one valid state to another but does not itself guarantee partial rollback. Isolation ensures concurrent transactions don't interfere with each other. Durability guarantees that once transaction commits, changes are permanent. Hence, atomicity is key to avoiding partial transactions after crash, reflecting foundational transaction theory. Question 7. Considering the evidence, Jacob is tasked with designing an entity relationship diagram for a hospital system. He must accurately represent the fact that each doctor can be assigned to multiple patients, but each patient has only one primary doctor. What type of relationship should Jacob use in his model? A. One-to-one relationship. B. One-to-many relationship. C. Many-to-many relationship. D. Many-to-one relationship. Answer. Correct answer. B. Explanation. A one-to-many relationship models the scenario where one entity, doctor, is associated with multiple instances of another entity, patients, but each instance of the second entity, patient, relates to only one instance of the first, primary doctor. In our modeling, the cardinality one-to-many correctly captures this asymmetry. Option A implies one doctor per patient and vice versa, which is incorrect. Many-to-many C would allow multiple doctors per patient. Not the case here. Many-to-one D is conceptually the same as one-to-many but from the opposite direction. Diagrams typically express relationships from their own side to many for clarity. This aligns with modeling best practices. Question 8. From a practical standpoint, Angela is managing a database with multiple users performing concurrent transactions. She wants to avoid the phenomenon of dirty reads, where transaction reads uncommitted data from another transaction. Which concurrency control mechanism should Angela implement? A. Timestamp ordering. B. Two-phase locking twople. C. Read uncommitted isolation level. D. Snapshot isolation. Answer. Correct answer. B. Explanation. Two-phase locking twople is a widely used concurrency control method ensuring serializability by acquiring all required locks before releasing any, preventing dirty reads, non-repeatable reads, and phantom reads. Timestamp ordering A also controls concurrency but is less commonly implemented and may be complex. Read uncommitted C allows dirty reads and is thus unsuitable. Snapshot isolation prevents dirty reads by providing a consistent snapshot but may allow other anomalies like write skew. TWAP aligns well with strict transaction isolation requirements and is grounded in concurrency control theory. Question 9. In the absence of a formal data dictionary, Tom is concerned about managing metadata and ensuring consistent data definitions across a large enterprise database. What critical function does a data dictionary provide to address Tom's concerns? A. It stores the actual data in secure format. B. It maintains centralized repository of metadata describing data elements, their types, relationships, and constraints. C. It performs query optimization to speed up database operations. D. It automatically enforces user access permissions. Answer. Correct answer. B. Explanation. The data dictionary acts as a centralized catalog that stores metadata. Information about data elements such as attribute names, data types, default values, constraints, relationships, and ownership. This metadata is crucial for database administrators and developers to maintain consistency, enforce standards, and improve understanding of data structures. It does not store actual user data. A. Perform query optimization. C. Or directly manage access control. D. It may support these indirectly. Active metadata management is fundamental best practice in database design and governance. Question 10. As illustrated by recent developments in database design, Sophia is trying to convert her conceptual model into a logical database schema using a relational model. During this translation, what must Sophia ensure about entity sets, relationships, and attributes? A. Entity sets become tables. The relationships are ignored in the relational model. B. Only entities with primary keys become tables. The relationships are represented by foreign keys or junction tables depending on cardinality. C. Attributes of relationships are discarded during conversion. D. All entities and relationships become a single flat table for simplicity. Answer. Correct answer. B. Explanation. In logical database design, entities with unique identifiers become tables. Relationships must be carefully represented. One-to-one or one-to-many relationships are typically modeled with foreign keys, while many-to-many relationships require junction tables. Attributes of relationships are preserved and usually become columns in these junction tables. Ignoring relationships, say, or discarding relationship attributes, C, breaks the integrity of the data model, flattening everything into one table. D, violates normalization and creates redundancy and anomalies. This step follows standard relational database design methodology and normalization principles. Question 11. While examining the database schema for a retail chain, Olivia realizes that some tables have redundant data, causing inconsistencies when updates are made. She suspects the design has violated normalization rules. If Olivia wants to ensure that every non-key attribute is fully functionally dependent on the entire primary key, what normalization level should she focus on achieving? A. First normal form 1th. B. Second normal form 2nd. C. Third normal form 3th. D. Boycott normal 4 year. Answer. Correct answer. B. Explanation. Second normal form, TWANF, addresses partial dependency issues, which occur when non-key attributes depend on part of the composite primary key rather than the whole. By achieving TWANF, Olivia can eliminate redundancy caused by partial dependencies, which is often a root cause of update anomalies. TWANF only ensures atomicity, not dependency issues. 3th addresses transitive dependencies of further stepworth. Stricter form of 3th, but usually not necessary unless anomalies persist. Thus, focusing on TWANF helps Olivia solve redundancy from partial dependency specifically. Question 12. From multiple perspectives, Marcus is analyzing a scenario where a database transaction reads data that is being modified by another concurrent transaction but has not yet been committed. This situation results in dirty reads. Which SQL transaction isolation level is most likely causing this phenomenon? A. Read committed. B. Serializable. C. Read uncommitted. D. Repeatable read. Answer. Correct answer. C. Explanation. The read uncommitted to isolation level allows transactions to read data that other transactions have modified but not yet committed. leading to dirty reads. This can cause inconsistencies if the modifying transaction is rolled back later. Read committed prevents dirty reads by only allowing access to committed data. Repeatable read and serializable provide even higher isolation, preventing non-repeatable reads and fan reads. Understanding isolation levels is crucial for managing concurrency control and ensuring data integrity. Question 13. In terms of database design lifecycle, Rachel is at the phase where she converts the conceptual model into a detailed logical schema defining tables, keys, and constraints. What is the primary objective of this logical database design phase? A. To physically create database files and indexes. B. To gather requirements from stakeholders. C. To translate the model into relational tables and define data types and constraints. D. To define storage parameters and performance tuning settings. Answer. Correct answer. C. Explanation. Logical database design focuses on translating the conceptual model into a logical schema that includes tables, primary and foreign keys, attribute domains, data types, and integrity constraints. It does not involve physical implementation aspects like file storage, date, or performance tuning. D. Requirement gathering. B. Happens earlier during analysis. This phase ensures that the logical schema accurately represents business rules and data relationships before physical creation. Question 14. Given the circumstances, David must enforce a rule in his database that prevents entering an order record without a valid customer record associated. Which type of integrity constraint best enforces this business rule? A. Domain integrity. B. Referential integrity. C. Entity integrity. D. User-defined integrity. Answer. Correct answer. B. Explanation. Referential integrity ensures that foreign keys in a child table orders correspond to valid primary keys in the parent table. Customers preventing orphan records. Domain integrity restricts attribute values to a valid range or type. Entity integrity ensures primary keys are unique and not null. User-defined integrity encompasses custom business rules beyond standard constraints. Enforcing referential integrity maintains consistency between related tables, critical for accurate relational data modeling. Question 15. Through the lens of structured query language (SQL), Samantha is tasked with retrieving all customers who have placed at least one order in the last month, but her initial select statement returns duplicates. Which SQL keyword should Samantha use to ensure her results list each customer only once? A. Distinct. B. Unique. C. Group by. D. Having. Answer. Correct answer. A. Explanation. The distinct keyword filters out duplicate rows in the result set, ensuring each customer appears only once. Unique is a constraint keyword not used in select statements. Group by aggregates rows based on specified columns, but alone does not eliminate duplicates unless combined with aggregate functions. Having filters groups after aggregation. Understanding these clauses is essential for crafting efficient and accurate SQL queries. Question 16. With respect to database security, Linda implements user authentication and assigns roles to control data access. However, she wants to prevent users from accidentally or maliciously executing unauthorized changes to database structure. Which SQL command category must Linda carefully restrict to enforce this? A. Data definition language (DDL). B. Data manipulation language (DML). C. Data control language (DCL). D. Transaction control language (TCL). Answer. Correct answer. A. Explanation. DDL commands create, alter, drop, modify database objects and schema. Unauthorized DDL execution can alter or delete critical structures, compromising integrity. DML commands modify data but not schema. DCL manages permissions and roles. TCL controls transaction processing. Restricting DDL access is a key security best practice to prevent structural changes by unauthorized users. Question 17. In light of recent developments, Jason encounters a relation where multiple attributes depend transitively on the primary key, e.g. B and B, C, so it's C indirectly. He wants to eliminate this anomaly, which normalization form addresses this issue explicitly. A. First normal form 1th. B. Second normal form 10th. C. Third normal form 3th. D. Boy Scout normal form E. Answer. Correct answer. See explanation. Third normal form, threenf, specifically targets transitive dependencies where non-key attributes depend on other non-key attributes rather than directly on the primary key. By moving these dependencies, threenf reduces redundancy and update anomalies. Onef ensures that emissity twonf handles partial dependencies, and esef, a stricter version of threenf addressing certain overlapping keys but is less commonly required. Understanding threenf is essential for robust logical database design. Question 18. Among the various join operations available in relational algebra and SQL, Rebecca needs to retrieve all records from table and matching records from table B, but also include records from table that have no match in table B. Which type of join should Rebecca use? A. Inner join. B. Left outer join. C. Right outer join. D. Full outer join. Answer. Correct answer. B. Explanation. A left outer join returns all rows from the left table, table A, and matching rows from the right table, table B. Rows in table A without matches in table B will appear with nulls for table B columns. Inner join returns only matched rows. Right outer join returns all rows from the right table and matching rows from left, and full outer join returns all rows from both tables. This knowledge is vital for querying related data accurately. Question 19. Taking into account concurrency control methods, Daniel observes that his database uses timestamping to order transactions and prevent conflicts. What is the main advantage of timestamp-based concurrency control compared to locking? A. It completely eliminates the need for rollback. B. It avoids deadlocks by not requiring locks. C. It guarantees serializability without aborting any transaction. D. It improves performance by allowing all transactions to run without any conflict checks. Answer. Correct answer. B. Explanation. Timestamp ordering assigns timestamps to transactions and ensures that conflicting operations respect these timestamps, avoiding the use of locks and therefore deadlocks. However, it may cause transaction aborts and restarts. To maintain consistency, locking methods can cause deadlocks if transactions wait for resources held by each other. Timestamping improves concurrency but does not eliminate rollbacks or guarantee no aborts. This method is a key concurrency control technique in distributed and high-performance databases. Question 20. For the purpose of optimizing query performance, Ethan is considering adding indexes to a large table. However, he wants to understand the trade-offs before proceeding. Which of the following statements accurately describes the impact of adding indexes? A. Indexes always improve insert and update performance without drawbacks. B. Indexes improve requery speed but may slow down insert, update, and delete operations due to maintenance overhead. C. Indexes reduce storage requirements by compressing data. D. Indexes eliminate the need for primary keys. Answer. Correct answer. B. Explanation. Indexes speed up read and search queries by allowing quick data access without full table scans. However, every insert, update, or delete operation on the index table must also update the index, incurring additional overhead and potentially slowing data modification. Indexes consume extra storage and do not replace the need for primary keys, which enforce uniqueness and entity integrity. Understanding this trade-off helps database designers balance performance and resource usage. Question 21. Under the assumption that Emma is designing a database for a logistics company where each shipment must be linked to exactly one delivery truck, but each truck can carry many shipments, she wants to ensure this relationship is accurately enforced in the relational schema. What is the best way to implement this constraint? A. Use a foreign key in the shipment table referencing the truck table's primary key. B. Create many-to-many junction table linking shipments and trucks. C. Store multiple truck IDs in single shipment record to track all trucks involved. D. Assign composite primary key to the truck table involving shipment IDs. Answer. Correct answer. Explanation. This describes a one-to-many relationship, one truck to many shipments, with each shipment assigned to exactly one truck. The standard approach is to add a foreign key in the many side table shipment pointing to the one side table truck. Many-to-many junction table B is unnecessary and incorrect here. Storing multiple truck IDs in one attribute C violates first normal form. Composite keys in the truck involving shipment IDs D do not logically represent this relationship. This enforces referential integrity and aligns with relational design principles. Question 22. The underlying principle of database transactions requires maintaining ACID properties. Jack submits a batch of orders, however, one order fails due to invalid data. What should the transaction management system do to maintain atomicity? A. Commit all valid orders and skip the invalid one. B. Roll back the entire transaction, including all previously processed orders in the batch. C. Partially commit the batch, marking invalid orders as exceptions. D. Leave the transaction open until manual intervention. Answer. Correct answer. B. Explanation. Atomicity guarantees that a transaction is indivisible. All operations succeed or none do. If any part fails, the entire transaction must be rolled back to maintain data integrity and prevent partial updates. Committing valid orders while skipping invalid ones they see violates atomicity and can cause inconsistent states. Leaving transactions open de-risks locking resources and does not resolve the failure. Fundamental ACID principle prevents corruption and enforces consistency. Question 23. Through careful analysis of a database schema, Sophia identifies an entity set of employees with composite primary key employee departmented. She finds an attribute department name dependent only on departmented. What normalization issue does this reveal? A. Partial dependency violating twonf. B. Transitive dependency violating threef. C. Domain violation in attribute data type. D. No normalization issues. Answer. Correct answer. A. Explanation. Partial dependency occurs when a non-key attribute depends on part of a composite primary key instead of the entire key. Here, department name depends only on departmented, not employed, causing redundancy if multiple employees belong to the same department. This violates second normal form twonf. Transitive dependency. B. Involves a non-key attribute depending on another non-key attribute. Primary key parts. This is a classic example requiring decomposition to eliminate partial dependency and adhere to twonf. Question 24. In comparison with relational algebra, SQL provides a more user-friendly interface for querying databases. However, certain operations in relational algebra do not have direct equivalents in basic SQL. Which relational algebra operation is most difficult to express directly in SQL without additional constructs? A. Selection S. B. Projection P. C. Set difference. D. Union V. Answer. Correct answer. C. Explanation. Set difference in relational algebra returns tuples in one relation but not in another. SQL has no direct except or minus operator in all implementations. Some do, but not standardized. It usually requires more complex queries with subqueries or not exists clauses. Selection and projection map directly to where and select clauses respectively. Union is supported via union operator in SQL. Understanding these differences is key for translating algebraic expressions into efficient SQL queries. Question 25. From a historical standpoint, Michael wants to ensure that every table in his database design has a unique identifier that cannot be null. What is the rationale behind enforcing entity integrity, and which rule enforces it? A. To prevent duplicate records by requiring unique primary keys. B. To ensure foreign keys always reference existing primary keys. C. To allow nulls in foreign key columns for optional relationships. D. To define default values for attributes. Answer. Correct answer. A. Explanation. Entity integrity requires that primary keys are unique and never null, ensuring each record can be uniquely identified. This prevents duplicate rows and supports reliable data retrieval and updates. Referential integrity. B. Deals with foreign keys referencing existing primary keys. Null foreign keys. C. Are allowed for optional relationships but do not violate entity integrity. Default values. D. Unrelated. Enforcing entity integrity is foundational to relational model consistency. Question 26. During the process of logical database design, Linda decides to implement surrogate keys instead of natural keys for certain entities, which is a valid reason for choosing surrogate keys. 8. Surrogate keys simplify indexing and improve performance by using fixed-size numeric values. B. Surrogate keys always carry business meaning, improving data readability. C. Surrogate keys prevent the need for foreign keys in related tables. D. Surrogate keys eliminate the need for normalization. Answer. Correct answer A. Explanation. Surrogate keys are system-generated identifiers, typically numeric and fixed size, that simplify indexing, joins, and performance optimization. They do not carry business meaning. B. Which sometimes reduces confusion if business attributes change. Surrogate keys do not remove the need for foreign keys. C. Nor do they impact normalization rules. D. Their use is a common best practice in logical design, improve efficiency, and maintain flexibility. Question 27. Demonstrated by concurrency control principles, Kevin's database supports multiple transactions running simultaneously. He notices that two transactions are waiting indefinitely for each other to release locks. What is this situation called, and what is common strategy to handle it? A. Starvation. Use priority scheduling. B. Deadlock. Detect cycles and abort one transaction. C. Live lock. Increase lock timeout. D. Race condition. Enforce stricter locking. Answer. Correct answer B. Explanation. Deadlock occurs when two or more transactions hold locks that prevent each other from progressing, causing indefinite waiting. Common handling involves deadlock detection algorithms that identify cycles in the wait for graph and abort one or more transactions to break the deadlock. Starvation is a different issue where a transaction waits indefinitely due to scheduling. Live lock. C is repeated state changes without race conditions. D are related but not synonymous with deadlocks. Handling deadlocks is essential in concurrency control. Question 20. The primary reason for using data manipulation language (DML) statements in SQL is to A. Define database objects like tables and indexes. B. Control user permissions and access levels. C. Retrieve and modify data within tables. D. Manage transaction commit and rollback. Answer. Correct answer C. Explanation. DML commands select, insert, update, delete are used to query and modify data stored within tables. Defining objects A is handled by DDL, user permissions. B are controlled by DCL, transaction management. D is done via TCL. Mastery of EML is essential for interacting with relational databases effectively. Question 29. In what ways can a database administrator use the data dictionary to improve database consistency? A. By modifying physical storage locations to optimize performance. B. By maintaining centralized metadata that enforces attribute data types and constraints. C. By writing custom application code to handle data validation. D. By manually updating data tables to correct inconsistencies. Answer. Correct answer B. Explanation. A data dictionary contains metadata describing database objects, attributes, domains, and constraints, ensuring uniform definitions and enforcement of data rules across the system. This reduces errors and inconsistency. Physical storage changes A in application code. C are outside the data dictionary's scope. Manual updates. D are reactive, not proactive methods for consistency. Using the dictionary aligns with best practices in metadata management. Question 30. Given the circumstances Alice is working with, a many-to-many relationship between students and clubs, she plans to create an associative table to handle this. What essential elements must this associative table include to correctly represent the relationship? A. Only the primary keys of students and clubs as foreign keys. B. Primary keys of students and clubs as foreign keys, plus any attributes specific to the relationship. C. All attributes of students and clubs combined in one table. D. A composite key formed only by a unique identifier unrelated to students or clubs. Answer. Correct answer B. Explanation. An associative junction table modeling many-to-many relationships contains foreign keys referencing the related table's primary keys to maintain referential integrity. It often includes composite primary key made from these foreign keys. Additionally, attributes specific to the relationship, like membership, date, or role, are stored here. Option A misses relationship-specific attributes. Option C violates normalization and duplicates data. Option D ignores the foreign key references. This design principle is fundamental in relational database modeling.